Hi, my name is Jim Ahrens, and I'm here to tell you today about Exascale Data Analytics and Visualization. I'm from Los Alamos National Laboratory, and I'm the Data and Visualization Lead for the Exascale Computing Project. So giving you an overview of the ECP Data and Visualization portfolio, probably one of the key challenges we're addressing is the notion that we're able to generate a lot more simulation output than we are able to store it on disk. So the box on the left represents this Exascale supercomputer, and one of the key solutions we're working on is in situ visualization and analysis. In particular, this is the concept of doing the analysis of the simulation while it's running. This requires new automated techniques that identify the most important features for saving out to disk. In addition, in the portfolio, we have data services like checkpoint restart and compression, as well as storage solutions like MPI-IO and HDF5. So we'll save that data out, reducing it, storing it to disk, and we'll look at it later in an interactive manner. So here's an example of a Exascale simulation, MFX-EXA. The project goal is to look at to simulate a chemical reactor to generate electricity. One thing people are concerned about is figuring out how to do carbon capture and from these reactors. And so if you look at the bubbles in the simulation on the right, you can see those are the features that are of interest to the scientists. So the challenge is to not save out the simulation results, which are large and you can only save them out rarely, but rather save out the features of these bubbles for later analysis and really reduce the amount of data you have to save. So specifically, you might save out imagery. You might also save out the bubble features and the sizes and etc., and then track them over time. That's what you can see in that post-hoc interface called Center Explorer on the right. Here's another simulation. It's called the WarpX simulation. It's a plasma accelerator design simulation, and the idea is to simulate these accelerators on a supercomputer. We automatically selected the contours via topological analysis, and as you can see, you can understand some of the features of the data set better with these contours. Finally, another example is this simulating internal combustion engines. We used machine learning with the Exascale machine learning project called Exalearn, and that helps us to find the ignition sites. And then at those ignition sites, we do visualization to help the scientists to understand where ignition is occurring in the simulation. For more information, please go to exascaleproject.org, and thanks for your time.